Topic 11, Part 2, Dispersion of light, or of white light, and electromagnetic spectrum. This one here is a continuous electromagnetic spectrum, of which visible light is only a small part. It goes from long wavelengths of radio waves to very short wavelengths of gamma rays. All electromagnetic waves travel at a speed of light, and this is the speed of light, which is 300 million meters per second. More about electromagnetic spectrum. Here, going from one crest of the waves to another crest is called a wavelength. Visible light says the 7 colors of the visible light, or the rainbow colors, when mixed together produce white light. Now we're going to disperse the visible light into its separate colors. We shine a ray of white light at a triangular glass prism, and as it enters the glass, the light ray bends towards the normal because it slows down. And it says here it is refracted towards the normal. Different colors are refracted by different angles or by different amounts because they all have slightly different refractive index in glass. Violet has the highest refractive index and bends the most, and red has the lowest refractive index and bends the least. This is what happens. The red refracts or bends or deviates the least. The violet refracts the most. Referring to this diagram, it says here, as the different colors of light leave the prism, they refract by different amounts again, causing further dispersion. You can see that. On the screen, which is here, rainbow colors can be seen as shown on the next slide. Remember this Roy G. Booth. And for exam purposes, you have to remember that the red is at the top, violet at the bottom. What is the real difference between red and violet light? Red light has longer wavelength. Monochromatic light is light of one color. Mono means one. Now we're looking at the electromagnetic spectrum in greater detail. For exam purposes, you just have to know the names of these important components of the spectrum. So at this end, with long wavelengths, you have radio waves, radio and TV waves, then microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Look at next slide. These key components again, commit them to memory. Another thing worth noting is the smaller the wavelength, the bigger the frequency.